ঠিক আছে। Okay, good afternoon all of you. In today's session we are going to do this topic, definite integral as limit of a sum. So today in this session we are going to do the topic definite integral as limit of a sum. So you want to find the area under a graph fx between the limits 0 to 1. Okay, between the limits 0 to 1 you want to find this area. So you know this area is integral 0 to 1 fx dx. That is how you have to find the area. Now this area can also be found as the limit of a sum, that is 1 by n by n limit n tends to infinity summation r equal to 1 to n f of r by n. So this is the integration 0 to 1 fx dx. You can also find it as the limit of a sum. So 1 by n limit n tends to infinity r equal to 1 to n f of r by n. So you can get the area by doing definite integral, and you can also get the area by doing limit of a sum. So there are two ways of doing it. So suppose you have a question like this: limit n factorial by n to the power n, n tends to infinity, like n factorial by n to the power n whole to the power n, n tends to infinity. This power will be 1 by n. So what you have to do is you have to write limit n tends to infinity 1 by n log log I can take this as y, so log y will be 1 by n log 1 2 3 up to n by n because n to the power n. So this right hand side will become limit n tends to infinity 1 by n summation r equal to 1 to n f of r by n, where fx is equal to log x. Okay, so I am taking this limit as y, so log y is limit n tends to infinity 1 by n log 1 into 2 into 3 up to n by n into n up to n. So limit n tends to infinity 1 by n summation r equal to 1 to n f of r by n, where fx is equal to log x. Now according to the theory, this entire limit is 0 to 1 fx, so this will be 0 to 1 log x dx. Okay, so this is the method. You have to find the limit of a sum, but you convert it to an integral and do it. So now you have to do integral 0 to 1 log x. So what you have to do is you have to do this integration by a method of by parts. So log x integral dx minus integral ddx of log x integral dx, the whole thing, this whole thing integral dx from 0 to 1. So this method is the method of by parts. So x log x, so this will be x log x and then minus integral dx. So this is 0 to 1 x log x minus x. So if you put 1 log 1 minus 1, it will be minus 1. If you put 0 log 0 minus 0. Now 0 log 0 is a little complicated because log 0 is actually undefined, but you have to multiply it with 0. So 0 log 0, if you take it as 0 and minus 0, so ultimately the answer is coming minus 1. So you started with log y and you are getting minus 1, so y will be 1 by e. So this is how to apply this particular formula. So in most cases the sum will be presented to you as a limit like this one, and you will have to convert the limit into an integral by using this as the theory. After that, the integral you will have to do, put the limits and get the answer. Okay, now let's have a look at this question. Find limit n tends to infinity 1 by 2n plus 1 by root over 4n square minus 1 plus 1 by root over 4n square minus 4, and last is 1 by root over 3n square plus 2n minus 1. You will have to find this limit. That is a question. Now, before I tell you how to do this question, just one thing I wanted to say. that in this formula, if the value of r is not 1 to n but it is 0 to n minus 1, then also it is applicable. That means so if the value of r is not 1 to n but 0 to n minus 1, then also this formula is applicable. So you can see that the first one can be written as 1 by root over 4n square, and the last one can be written as 1 by root over 4n square minus n minus 1 square. So this is coming So this is coming 1 by n, limit n tends to infinity, 0 to n minus 1, 1 by root over 4 minus r by n whole square. So according to this formula, this will become 0 to 1 dx by root over 4 minus x square, and dx by 4 minus x square is sine inverse x by 2 from 0 to 1. If you put 1, the answer will be pi by 6. If you put 0, the answer will be 0. So finally the answer of this question is pi by 6. So this was the sum. We first identified the first term and last term. Then we saw that it is coming 0 to n minus 1. So we wrote this as the limit of a sum. So 1 by n, limit n tends to infinity, summation 0 to n minus 1, 1 by root over 4 minus r by n whole square. So as per this formula, this becomes 0 to 1 dx by root over 4 minus x square. So sine inverse x by 2 from 0 to 1, if you put the limits and solve, it's coming to pi by 6. So we have seen one sum with 1 to n, we have seen one sum with 0 to n minus 1. What other sum can be there? Sometimes there is a possibility that it will not be 1 to n, it will not be 0 to n minus 1, but it will be 0 to it will be 1 to some multiple of n. Let's have a look at one sum. So limit n tends to infinity, 1 by n plus 1 plus 1 by n plus 2 dot 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 1 by 6n. This is the question. So in this question, it is coming 1 by n So 1 by n, limit n tends to infinity, summation r equal to 1 to 5n, 1 plus r by n. So it will be So instead of 0 to 1, because it is 5 times of n, it will be 0 to 5. So this is log 1 plus x from 0 to 5. So the answer will be log 6. So because the limit is not n, it is 5n. So integral will be 0 to 5 and the answer will be log 6. So this is the topic. This topic we have done today, and now I'll give you some homework. I'll give you some homework based on this topic. So limit n tends to infinity 1 by 1 plus n cube, 4 by 8 plus n cube up to 1 by 2, and this is question number 1. Question number 2. So limit n tends to infinity 1 by n, sine pi by 2n plus sine 2 pi by 2n, and last is sine n pi by 2n. Third one, limit n tends to infinity r equal to 1 to n, 1 by n tan r pi by 4n. Limit n tends to infinity n by n square plus 1 square up to n by n square plus n square. Limit n tends to infinity 1 by n plus 1, 1 by n plus 2 up to 1 by pn. So these are the 5 sums for homework based on the topic integral, definite integral as limit of a sum. Okay, these are the 5 sums: 1, 2, 3, 4, 5. Limit n tends to infinity 1 by 1 plus n cube, 4 by 8 plus n cube, dot 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 up to 1 by 2n. Number 2, limit n tends to infinity 1 by n, sine pi by 2n, sine 2 pi by 2n up to sine n pi by 2n. Number 3, limit n tends to infinity summation r equal to 1 by n, 1 to n, 1 by n tan r pi by 4n. Number 4, limit n tends to infinity n by n square plus 1 square up to n by n square plus n square. Number 5, limit n tends to infinity 1 by n plus 1 plus 1 by n plus 2 up to 1 by pn. So that completes the session. I am ending the session and we will continue on Monday. Because on Sunday we don't have any streams. So Monday, and you can do the homework by 9 p.m. on Monday. Thanks a lot. I'll end the stream.